Welcome to qnawire.
So in this problem, we are given three solutions and we are asked to calculate the initial and final pH of each solution after addition of 0.010 mole of HCl in each of the solutions. So let's start with the first one. So in first one, we have 500 ml of pure water. So as we know that the pure water has a pH of 7, so the initial pH for this case will be 7.00, and we are adding 0.010 mole HCl, and the volume of the solution or the volume of the water is 500 milliliter. So if we find the concentration of the acid, it will be 0.0 oh, 0.010 mole of HCl over the volume, which is 0.500 liter, and then we'll have the concentration of the HCl as 0.020 m HCl. So that is the HCl we are adding, and since HCl is a strong acid, it will be dissociated completely in the solution, and the pH of the final pH of the solution will be simply the negative log of this concentration, or the H plus concentration, which is 0.020, and we will have a value of 1.70. So this is the final pH of the pure water after addition of 0.010 mole HCl. Now in second case, or the second solution, we have a 500 ml buffer of 0.125 molar Hc2H3O2 and 0.115 molar NaC2H3O2. So the initial concentration, also the initial pH of the solution will be simply just we plug in the values in Henderson-Hasselbalch equation, in because the pH is equal to pKa, and the Ka value for the acid here is 1.8 times 10 to the power minus 5. So if we just take the negative log of that, we will have the pKa value as 4.74 plus log of our base concentration, which is 0.115 over our acid concentration, which is 0.125, and then calculating the or solving the equation, we will have the initial pH of this solution as 4.71. So this is our initial pH for this solution, and then after addition of 0.010 mole HCl, so since this solution is also 500 ml buffer, so first we find the first we have to find the number of moles of the acid and base present here, and then we will have to set up the equation of the reaction in the buffer after the addition of HCl. So the HCl will react with the base of the buffer, and which is in a C2H3O2, and we'll find HC2 H3O2 from here plus the salt sodium chloride. Now we are adding 0.010 mole of this HCl, which will react with 0.010 mole of our base and will produce 0.010 mole of the acid. So that will just add this mole with the initial number of moles of the acid, and this amount will be subtracted from the initial number of mole of the base. So if we calculate, um, so we know the initial concentration of the base and acid. So if we just multiply the concentration, so this is our base concentration, the concentration of this. If we just multiply this value by the volume of the solution, which is 500 milliliter or zero 0.5 liter, we will have the number of moles of this base as 0.0575. So in the resultant solution, we will have this much mole subtracted from this amount, and ultimately we will have 0.0475 mole of the base. And also in case of the acid, our initial number of moles will be just multiplying this concentration, which is the acid concentration, by the volume of the solution, and we will have the number of moles of acid as 0.0625 mole. And then in the resulting solution, we will add this much to this amount, and we will have 0.0725 mole of acid. Now we know the new number of moles of base and acid. If we just plug in these values in the equation of the Henderson-Hasselbalch equation, we will have the new pH. So the pH will be pKa. So the pKa is again the negative log of the Ka of the acid, which is 1.8 times 10 to the power minus 5. And taking the negative log of that value, we get the pKa as 4.74 plus log of the number of moles of base, which is 0.0475 over the number of moles of acid, which is 0.0725, and then eventually we will have a pH of 4.56. So this is the pH of the buffer in B after the addition of 0.010 moles of HCl. Now let's go to the third solution. So for the third one, we have again 500 ml buffer of 0.155 m C2H5NH2 and 0.145 m C2H5NH3Cl. So here our base is C2H5NH2. This is our weak base with a concentration of 0.155 molar, and our conjugate acid here is C2H5NH3Cl, which is our conjugate acid with a concentration of 0.145 molar. Now So our initial pH will be simply the application of Henderson-Hasselbalch equation. So here, since it's a basic solution, we can find the Kb value of this base, and if we just take the negative log of the Kb value, we'll have the pKb, and just subtracting the pKb value from 14, we can have the pKa value, which is 10.75. This is the pKa value of this for this solution, and then we just add the log of our basic concentration over our acid concentration, and this way we will have our pH or initial pH of the solution as 10.78. So this is the initial pH of this solution. Then after the addition of 0.010 mole HCl, what will happen is this HCl will react with our base C2H5NH2, and we will get C2H5NH3Cl. So all of them are aqueous. Now, before the addition of HCl, we had a so what is the number of moles of this base? So the concentration of the base is 0.155 molar, and if we just multiply the concentration of the base by the volume of the solution, which is 500 milliliter or 0.5 liter, just multiplying these two value, we will get the number of moles of this base here, which is 0.0775. And in the same way, we will get the number of moles of the acid as 0.0725 mole. Now we are adding 0.010 mole HCl, which will react with 0.010 mole of the base, and ultimately it will decrease these moles from the base, and the resulting base mole will be 0.0675 mole, and we are actually adding 0.010 mole to our acid amount, and the resultant amount of the acid will be 0.0825 mole. Now we have a new moles for base and acid. We just plug them in our Henderson-Hasselbalch equation, and the final pH will be pKa. Since the pKa is already, we have said how to find the pKa, that is 10.75, the pKa value for this solution, and we just add the log of our new number of moles of our base, 0.0675, over the number of moles of acid, 0.0825. So these are the new number of moles of base and acid after the addition of 0.010 mole HCl. And just solving this equation, we will have a pH value of 10.66. So this will be the final pH of the solution C after the addition of 0.010 mole HCl.